with the slope be the same for each other? Yeah, would the slope be the same?
So Labaya said if the graph is not linear, so if we're not dealing with a line, so let us say, for example, it looked something like this. And some relationships could come out looking like that. So if the graph is not linear, she's saying, would the slopes be the same? Any thoughts? I'd love to hear from you guys. So let's whip around the room real quickly. Georgie, first hand us off.
They would not be the same because if the line was linear, it means it's proportional.
Okay.
It's not proportional.
Okay. All right, let me keep going. Anybody else want to add to that?
Like, it has to have a proportional relationship because if it's not, then you're going to have different ratios. So.
All right, anybody else want to add anything else to that? How about, let me plan, put something out there. What do we mean by the slope again? So let's think about what exactly is a slope measuring. We talk about the slope of a line. What do we mean?
When you say the slope of a line, you mean the measure of the rise of the moon?
True, and if I were to, why is it that the slope of this line was larger than the slope of that one? Because slope really is measuring what? I can find the slope of a roadway. I could find the slope of a ramp. So what is it really measuring? One word.
Height.
Anybody wants to add to that? Tony?
Steepness.
So it's really measuring the steepness. So I want to plant something in your thoughts. Okay, so you ready? Eyes are on me, and we're still. So thinking about what slope really means, and so far I like all the answers, why would you not expect the slope to be the same everywhere along this graph? So we know slope is really talking about the steepness of the line, so to speak, or the graph. So why wouldn't you expect it to be the same? So who has not spoken yet? Why wouldn't you accept the steepness? Aaliyah. Thank you for those giving cats. It's a sign of respect. It's being courteous.
Wouldn't you not get a right triangle?
Okay, let me see. That's one way of looking at it. And can you, what did Tony say slope really means again? It's measuring what? The steepness. Look at this curve. What can you tell me about the steepness as we are progressing along this curve, Aaliyah? Would you say the steepness is the same everywhere?
No.
Would you say the steepness is the same?
Oh, no.
Well, describe it. What would you tell me about the slope?
The slope is going up.
So it's getting
High.
steeper and it's getting steeper, isn't that so? So that's one way of answering your question, Lamaya. Many of you did. So the slope would not be the same if it is not linear. Are we good so far? And the very question she just asked a moment ago, your eyes are still on me, let it stay. The very question Lamaya just asked a while ago is a concept that goes all the way to calculus, believe it or not. All right, so I appreciate you asking that. Fair enough? Okay. All right, yes, Kayla.
It's like we was learning science.
We were.
We were learning science. It's like acceleration, and the more you accelerate, the definition is.
That is such a good connection. So you were learning in science to compare velocity with time, am I right? And if the velocity, let us say we're comparing, good question. So let us say this is velocity of a car, for example. Is that okay? Eyes are on me, Drew. And let's say we're comparing it over a certain time period, right? If the relationship comes out like that, what can you tell me about the rate of change of velocity with time? So what can you tell me about the acceleration? What can you say about the acceleration here? I'm curious. You want to pass it quickly?
The rate is constant.
The rate is constant. In this case, we would say the acceleration is constant. Isn't that so? What if it looked like that? What could we say about the rate of change of this car? What would you say about the acceleration? What would you say about the acceleration? Malicious? It is getting steeper as time progresses. The velocity is increasing, isn't that so? So what would you say about the acceleration? Is it the same? No, so it's getting, or how would you say this car is traveling then? Faster and faster, and it's changing not by the same amount, isn't that so? Is everybody okay so far? Alright, and I really, really like the connection there. Don't you, Mrs. Stallings? Very, very good connection right there. Okay? Alright, if you will, for me, just flip over to the second page. And as always, please refer to the person who's next to you. Each one teach one. I'm going to give you about 2 minutes to look at number 7 and number 8. Compare with the person who's next to you. And then we're going to look on some relationships. So we're on this page right now. Take a moment and just answer 7 and 8. And also compare with the person who's sitting next to you. 2 minutes. And yes, you can check with the person who's next to you. You can just tell me what it is. Yes.
So we don't have to.
You don't. You could, since we're just learning.
So we had to take 1/3, 1/3, and then we related to concept of the slope.
The line is linear. So
The first half is the
So y equals 1/3 x. So when I would chart,
it's the same.
It's 8. It's 8.
when I'm done,
What's the first value of the line? Y.
No, it's on our graph or it's
Which has a greater slope? How does this affect the appearance of the line? This line is steeper, and this line
See, this is K right there.
But still, they tell what K is.
This is Y equals 1/3 X K.
Oh. So it's saying Y is.
Yeah, it is. It is taller. Well, it looks like it makes it look like it's longer.
this graph. Look back over here. What was the slope of the line?